Let's say you work in a small medtech company that is considering to develop a new medical device. Let's assume for this example that it will take an upfront investment of €100,000 and 1 year of engineering to make the device. You are approached by a firm that is interested in buying your product for €105,000 after the 1 year period of engineering is completed. This sounds like a good deal since you will earn €5,000. Or in other words, the net value of this project is €5,000. However, we only calculated the project's net value, while what we are really interested in is the net present value, or NPV. Here, present means today, meaning we want to transform the value of a future cash flow to a value today. So, when calculating the NPV, we have to take the factors time and interest rates into consideration. What if you decide not to invest in developing the new medical device, but instead put the €100,000 in the bank against an interest rate of 6%? Now, in 1 year time, you will earn €6,000. Your €100,000 today represents a value of €106,000 next year. We can also reverse that statement by saying €106,000 next year is the same as €100,000 today. Now, let's return to your medical device project. How do we get the net present value that takes time and interest rate, or more accurately, the discount factor, into consideration? The first step is to calculate the present value of the cash flow in year 1 by using this formula, where CF is the cash flow at year 1, in our example €105,000, I is the discount factor, in this case the interest rate of 6%, and the time period in this example is 1 year. In other words, €105,000 next year is the same as €99,057 today. The next step is calculating the net present value, which is a combination of the initial investment and the cash flow at year 1 in today's value. For this, we use the general formula for NPV, so we can include an initial investment at year 0. In our example, €100,000. In our example, the NPV will be minus €943. That is a lot less than a net value of €5,000 we calculated earlier. Our net present value is negative, indicating that you lose €943 if you compare it to depositing your money at the bank. The net present value calculations are commonly used to decide whether to accept or reject a project. When the NPV is negative, as it was in our example, the company will decide to reject the project and will not invest in it. Now let's return for a moment to our initial formula for the NPV calculation that covers 1 year. Of course, in the medical field, product development will take many years. So let's have a look at a novel medical intervention project with a length of 20 years. We assume there's an investment stage of 10 years for R&D, the approval at the 10-year mark by the authorities, and a revenue stage of 10 years in which patients are being treated with the new intervention. Let's say that your project will require an upfront investment of €100,000 to get the project going and do preclinical research to test your idea for a novel product. Thus, we lay out €100,000 to start the project. This is an investment, or cash outflow. At the end of year 1, we have invested another €1,900,000. At the end of year 2, €3 million, etc. And finally, by the end of year 10, the last investment year, we have invested a total of €175 million. At year 10, our product is registered, and there is reimbursement once the project is used to treat patients. At the end of year 11, we have a net revenue of €15 million. The subsequent years, the revenues are gradually increasing each year. By the end of the last year of our project, the net revenues accumulate to a total of €400 million. We now want to look at the yearly cash flows to account for the time value of money. After all, we know that €30 million at year 5 is not worth €30 million today. So we need to calculate the present value of each cash flow in each year. Again, let's use a discount rate of 6%. For each cash flow, we will discount it back to period 0. As we have seen in the first example, we don't have to discount today's upfront investment of €100,000 because we know that is the value of today. But we do want to discount all other cash flows. For instance, the present value of the cash flow at year 11 is €7,901,813. To calculate the net present value, we'll have to sum up the present values of each year. The NPV is positive, so you may decide to initiate the project. The question remains, can we use this information to decide whether or not to invest in a novel medical intervention? After all, we know that many projects fail during the development process, something that is not taken into account in this NPV calculation. This is why industry often prefers a risk-adjusted NPV, or RNPV. In finance, RNPV is a method to value risky future cash flows. RNPV modifies the standard NPV calculation by multiplying each cash flow by the estimated success rate, for instance by correcting for overall success rates for different R&D phases. To illustrate this, let's look again at our hypothetical 20 years project. And for the sake of simplicity, let's define hypothetical development stages A, B and C, and the patient treatment stage. Let's set transition success rates to progress through these stages at 70%, 50% and 85% respectively. In this example, the chance you will actually successfully pass all development stages to the patient treatment phase is only 30%. To calculate the risk-adjusted NPV, all present values for future cash flows, investments and revenues are first simply corrected for the chance that you'll actually reach that stage. For instance, let's take a look at year 11. We have to multiply the revenues of year 11 by the chance you will actually reach that stage, in this case 30%. Risk adjustment obviously results in a much lower value. Next, the sum of all these risk-adjusted present values add to a risk-adjusted net present value. Because this value now incorporates a substantial development risk of reaching the revenue stage, the risk-adjusted net present value is much lower than the NPV. In this case, the RNPV is even negative, indicating that with this discount rate and these development risks, it is not worth initiating this project,